Number 29. Typical backyard ants often create a network of chemical trails for guidance, extending outward from the nest. A trail branches repeatedly, with 60 degrees between the branches. If a roaming ant chances upon a trail, it can tell the way to the nest at any branch point. If it's moving away from the nest, it has two choices of path requiring a small turn in its travel direction, either 30 degrees leftward or 30 degrees rightward. If it's moving towards the nest, it has only one such choice. So this figure over here shows a typical ant trail with ladder straight sections of 2 centimeters length and symmetric bifurcation of 60 degrees. Path V is parallel to the y-axis, so this path over here. And what are the magnitude and the angle relative to the positive direction of the superimposed axis of an ant's displacement from the nest if the ant enters the trail at point A? What are the magnitude and the angle if the ant enters at point B? So the first thing that we have to do is to find the nest of the ants, which is pretty simple. It is this point over here, because we can see that if we are going from the nest towards somewhere else, the ant have two different options, each one making 30 degrees leftwards or 30 degrees rightwards. That's what he says over here. However, if you're going from this direction to this direction, you can make a small turn, which this is 30 degrees, or a big turn, which is 60 degrees. So this is how an ant knows how to find its way to the nest, because just go to the small turn over here. However, if you're going from this point to that point, you have two different options, so that's how the ant can locate itself. Okay, anyway, so this is what we have to find. So let's go for letter A. So for letter A, we have to find this vector over here. Let's call this vector A. And vector A is the sum of four different vectors: vector W, vector V, vector I, and vector H. So vector A is the sum of vector W plus vector V plus vector I plus vector H. So we have to find those four vectors over here, and then we can find vector A. That's what we have to do. So you can see that vector V is parallel to the y direction. So this is 60 degrees. So we can see that the angle between vector W and vector V, this angle over here, the small angle, is 30 degrees. So if we sum this angle over here, let's call it alpha. Alpha plus 30 equals to 90 degrees. So we know that alpha is equal to 60 degrees, okay? So vector W is equal to the magnitude of the vector times the cosine of 60, let's call it alpha, in the I direction, plus the magnitude of the vector times the sine of alpha in the J direction. So I'm just using letters here instead of numbers, and then at the end you can do that by yourself, because this is not a simple exercise. I'm going to suppose that you can do the small steps by yourself, or else we are going to stay here for like half an hour, I guess. Okay, anyway, so this is vector W. Remember that the magnitude of the vector is 2 centimeters. So the magnitude of any of those small vectors are 2 centimeters. So vector V is just 2 centimeters in the y direction, because it points upwards. So vector V is just the magnitude of vector V in the J direction. Vector I, so this angle over here now, this angle with respect to the X direction is equal to 120 degrees, because it's 60 plus 60 degrees. And this vector is going to be the magnitude of the vector times the cosine of 120 degrees in the I direction, plus the magnitude of the vector times the sine of 120 degrees in the j direction. So this is vector I. Vector h is the same as vector v, which points in the j direction. So if we sum everything up, remember that this angle over here is 60 degrees. And the magnitude of the 4 vectors is 2 centimeters, okay? So don't forget that. So if we sum everything up, we are going to find 2 plus the square root of 3 times 2 centimeters. Let's use meters. So 0.02 meters in the j direction. Don't forget to include the unit, which is meters, because we choose to use meters in the magnitude of the vectors. Okay, so this is vector A in unit vector notation. The magnitude of vector A is equal to the square root of this term squared. So 2 plus the square root of 3 times 0.02, and everything is squared, and this gives us 0.075 meters. So this is the magnitude of this vector over here, about 7.5 centimeters, exactly 7.5 centimeters. As for letter B, we have to find this angle over here, right? You could notice that this angle makes 90 degrees. However, you can prove it by doing the calculations, and the angle is equal to the tangent to the -1 of the y component of vector A over the x component of vector A, and this gives us 90 degrees. So this is how you can prove it using calculations. Okay, this is the answer of letter A and letter B. For letter C and D, we have to do the same thing. However, now we have to do that for vector B, which is this one over here. Okay, so not perfect. Okay, so this is vector B. And then we have to choose which path we're going to take. So let's go, because we have two different, no, this is not a path. Okay, over here you cannot cross from this point to that point over there. Okay, so you can only use one path, which is this one over here. So I have to go to the H, V, J, P, and O. So vector B is equal to vector W plus vector V plus vector J plus vector P plus vector O. We already calculated those two vectors, so we just have to calculate the vector J, P, and O. That's all we have to do. Vector J. So this over here is 60 degrees. So vector J is equal to the magnitude of the vector times the cosine of 60 degrees in the I direction plus the magnitude of the vector times the sine of 60 degrees in the J direction. So this is vector J. Vector P, so this is 30 degrees. How do you know it's 30 degrees? Because this over here is 30, so it's 60 minus 30 degrees, which is 30. Okay, so this is the magnitude of the vector times the cosine of 30 degrees in the I direction plus the magnitude of the vector times the sine of 30 degrees in the J direction, and vector O is just the magnitude of the vector in the I direction. Okay, so you just have to sum everything up. Just sum the vectors. Now you have everything. And if you do that, you're going to find 2 plus the square root of 3 over 2 times 0.02 in the I direction plus 3 over 2 plus the square root of 3 times 0.02 in the j direction, and everything is in meters over here. Okay, so this is vector B. For letter C, we want to find the magnitude of that vector. So the magnitude of vector B is going to be the square root of the x component squared plus the y component squared. Remember that this is the x component and this is the y component. And if you do this calculation, you would find, let's see, 0.086 meters. So this is the answer of letter C. For letter D, we have to find the angle, which is equal to the tangent to the -1 of by over bx, which gives us, let's see, the answer gives us 48 degrees. So this is the answer of letter D.